Here's the design that I came up with by looking at some other examples. But there's one resistor, the one at the lower left, question mark K. What I'm going to do here is I've got a variable resistor at this point, and I'm going to change the variable resistor until the signal that I put in will, when I overdrive this, by the way, with the signal, it bottoms out and also flat tops approximately at the same time. The red arrow is where I have the oscilloscope connected, and I did change the variable resistor and change the input, overdriving it, until, as you can see, it flat tops and bottoms out approximately at the same time. I have removed the variable resistor, and now I'm measuring what that resistance is, and it's 1089 ohms. Well, I don't have that. I do have 1000 ohms, and this one reads 989 ohms. So I have installed that in the circuit, and I'm going to hook the scope back up, and we'll take a look and see what it looks like with that 1000 ohm resistor. The oscilloscope is still hooked in the same place, and now I'm going to increase the signal, and you can see that it tops out a little before it bottoms out, but it's pretty good. I decided to put another stage on this and cascade them together, and you'll notice that the capacitor that links the two stages together is a .033 microfarads. That's because when I tried to use another 22 microfarad, it just overdrove the second stage so much it was unusable. So I had to change the capacitance that coupled the two stages together. Now the input, I still haven't changed the level on the first stage, so it starts out with a flat top and flat bottom, but when I lower the input, it does turn into a pretty good sine wave. The red arrow is where I have the oscilloscope on the output of the last stage, and you can see that it's easy to overdrive the thing with a strong signal, but I can adjust it to a pretty nice sine wave. Now I'm going to move that oscilloscope to the first stage output, and you can see that at that point the signal is less, and now I'm going to show what the input signal is like. So with those two stages, we do get some pretty good and accurate amplification. Here's the results of this little two-stage audio amplifier. All the way to the left, we have a very low audio input, and the first stage amplifies it, and that gets coupled to the second stage input, which amplifies it again. Now, due to the scope syncing the signal, the center waveform actually should be 180 degrees out of phase. Thanks for watching.